Good evening, Year 11. This is your night before news for your maths higher paper 2, which will be tomorrow morning. Paper 2 is a calculated paper, and like normal, the hub will be open from 7 AM for you to come in for some breakfast revision before we go to our lineups. As with any set of exams, once we start to sit the papers, we can start to think about what topics we haven't seen yet and what things haven't come up. So just I had to think about what came up in paper 1. And these are some of the topics that haven't yet come up. So possibly will come up either in tomorrow's paper or in paper 3. Have a little look through those, and if you're thinking about trying to do some extra revision this evening, picking one of those things, one of these topics is likely to be quite sensible. I've just chosen, again, like usual, a couple of these to go through now with you this evening. I'll do one, and then you can have a go at a similar one, and then have a look at the answer and mark it and see how you did. So the first one that I've chosen is circle theorems. Let's have a look at our diagram on the right hand side then. So we've got a couple of triangles formed inside of this circle, and they have given us these hatch lines, so we know that this triangle here is a isosceles triangle, and this triangle over on this side is a different isosceles triangle. They've told us that angle ABD is 50 degrees, that's also marked on the diagram, and what we've been asked to work out is angle ADE. So if I join A to D to E, that's going to be this angle here. So the way we'd answer this question is we think about, well, what do we possibly know and how can we use that to work out something? So we've been told that angle ABD is 50, so the only really thing we can do now is use that to work out some other angles. So because it's part of an isosceles triangle, we can use the fact that the base angles in an isosceles triangle are always equal. So we can say that angle BAD would be equal to angle BDA, and we can calculate that by doing 180, take away the 50 degrees, and then dividing it by 2. If those base angles need to be equal, and we know that angles in a triangle have to sum to 180. That's going to give us 130. We can divide that by 2, and we get 65 degrees. The question does very clearly say that we need to give a reason for each stage of our working, so we just have to write down our reasons here. Okay, so angles in a triangle sum to 180, and also that base angles in an isosceles triangle are equal. Okay, if you have a quick think now about some other bits of information we can take from this diagram now, and I'm thinking in particular about the fact that we are looking at shapes inside of circles, so circle theorem should very much be on our minds. And I've now got this angle here being 65 degrees. There is a relationship then between the 65 degrees and this angle here, angle BCD, and that is all to do with the fact that this is a quadrilateral where all of those vertices lie on the circumference. So that means that those opposite angles, they have to sum to 180. So we can now say that angle BCD is equal to 180, take away that 65 degree angle, which is going to leave us with 115 degrees, which again we can mark onto the diagram, and we need to give that reason. So our reason was sum to 180 degrees. Sorry, that should say opposite angles. Okay. We've then got this second isosceles triangle. So now that we know that that angle there is 115, we can work out what our base angles would be. Okay, and that's going to be useful because these three angles here need to form a straight line, which is 180 degrees. So we can say that angle CDA is equal to 180, take away 115, and then divided by 2. So 180 take away 115 is going to give us 65, and then we're going to half that, which is going to give us 32.5 degrees. And we can now just repeat that reason, that base angles in an isosceles triangle are equal, and we can do our final bit of working out, which is to find angle ADE. That's going to be equal to 180, take away our 32.5 and our what was it, 65, and that should leave us with, if we just do a quick calculation on my calculator, 82.5 degrees, and our final reason was that angles on a straight line sum to 180 degrees, and therefore we've got our answer. Here's a similar one. If you just pause the video now, have a go at answering that question, and then when you're ready to look through the mark scheme, unpause the video and we can mark that. Okay, here's your answer here. So you can see on the actual mark scheme here alongside my work solution that the first mark is given for the method to find angles BDA and BCD. So if we can see that method being used, we're going to be getting that one mark, that first mark for the question. And for having the two correct reasons, we're going to be getting our second mark. The third mark is working out what angle ADC is, so that's going to be 40 degrees. And then listing our reason again is going to be another conclusion mark. And our final accuracy mark, you can see in the mark scheme here, is for working it out to be 60, but with the appropriate reason. Okay, and that's 5 marks in total. So you can see without any of the reasons given here, you've got 2 marks maximum. Okay, so if we're going to solve this pair of simultaneous equations, we need to first of all look at our linear equation, and we need to rearrange that to make either x or y the subject. I would always advise going for what looks to be the easiest option, so I'd try to avoid making a fraction where I can. Unfortunately, I won't be able to avoid that here, so I chose to make y the subject, so we're going to take away the 3x, so 7 take away 3x, and then we can divide through by 4. Now this is what I want to be substituting in then into our non-linear simultaneous equation. So in this case, that's x squared minus 4y squared equals 9. So we can't do anything to the x squared, but we are subtracting 4 lots of y all squared, which we can now express in terms of x as 7 minus 3x over 4. So we now have what will be a quadratic equation just in terms of x, which means we're going to be able to solve it either by factorising or using the quadratic formula. But to do so, we're going to need to obviously simplify this and set it equal to 0. So let's deal with that bracket there. If I'm squaring a bracket, that does just mean that I'm squaring the numerator. Sorry, I'm squaring a fraction. I'm squaring the numerator and I'm squaring the denominator. So I will need to expand and simplify that double bracket in my numerator, but if I square my denominator, I'm going to get 16, and that's still equal to 9. I can simplify that. If I divide through by 4, that's going to give me 7 minus 3x all squared over 4. And let's get rid of that fraction now by multiplying through by 4. So 4x squared minus 7 minus 3x all squared. And I've got to multiply that 9 by 4 as well. That gives me 36. So now we need to expand the bracket. You're probably more than happy doing that without using a grid. I know some of you like to, so I'm just drawing that over at the side here. Obviously you've got FOIL method, and some of you will be pretty confident at doing that in your head. We can collect our negative 21x's here, and we can pop that into our equation. I'm going to keep all of that inside a bracket because I do need to remember that I am subtracting all of these terms. So we get a 9x squared, a minus 42x, and a plus 49. So let's just do that term by term. 4x squared, I'm going to take away that 9x squared, it's going to give us a negative 5x squared. We're subtracting a negative 42x, which is going to give us a positive 42x, and we're subtracting a positive 49, which is going to give us a negative 49. I want this all, I want all of this to equal 0 so that I can solve it. I'd rather not have to deal with trying to factorise or solve with a negative x squared, so I'm going to add it all across. So if I add my 5x squared on, we would have 5x squared plus 36 on the right hand side. If I take away the 42x, that leaves us with negative 49 equals 5x squared minus 42x plus 36, and then add on your 49. We get 5x squared minus 42x plus 85. So now I've got myself a 3-term quadratic which is equal to 0. We can look to solve this. I have noticed that all of my terms look at divisible. Oh no, they're not. No, sorry, they're not divisible by 5. Clearly 42 isn't. So we're just going to be factorising this. Okay. I know it's going to be double bracket. And 5x squared, well, the only way I can get that is if I start my brackets with 5x and x. This is not the kindest factorising to do, and actually you do have a calculator, so you could, if you wanted to, just use the quadratic formula here. This does factorise, but it might take you a while to find the factors, so default to using the formula if necessary, because you've got your calculator. Okay, but what I was thinking about was factors of 85. It clearly does end in a 5, so what is 85 divided by 5? Well, that's going to be that's not working, 17 times by 5. Okay, and if I think about that, does that work? Am I going to get a 42x from it? Well, yes. If I have my 5 here, when I expand that, I'm going to have 25, and I can use my 25 and my 17 to get a negative 42. Okay, they would both need to be negative in order to make sure we had that positive 85, and then that's going to give me the negative 42x. So from there we can get our two solutions. 5x minus 17 equals 0, so therefore 5x equals 17, x equals 17 over 5, and here x minus 5 equals 0, so therefore x equals 5. Because it's simultaneous equations, we now need to substitute those values into our formula to work out what y is when x takes those values. So when y when x equals 5, y equals, and we already went through some effort earlier of rearranging to get y as the subject. Okay, so we know that when y is equal to 7 minus 3x all over 4, so that's going to be 7 minus 3 lots of 5 over 4. So 7 minus 15 over 4 minus 8 over 4, which is negative 2. We've also got our second solution, so when x is equal to 17 over 5, y is equal to 7 minus 3 lots of 17 over 5, and all of that is being divided by 4. Again, you do have a calculator to help you with this, so you could type all of that in, and I believe that that gives you minus, I'm just going to check on my calculator, yeah, minus 4/5. So your two solutions are x equals 5 and y equals minus 2, and x equals 17 over 5 and y equals negative 4/5. Have a go at this similar question, pause it, and then unpause when you're ready to go for the answers. Okay, so here is our mark scheme, and here's my working out. If we're just comparing these, then your first mark look comes from method to find an expression for y to substitute into x squared minus y over 14. Unfortunately, just then when I use the rubber, it has rubbed out a bit of this working out. So that would have said that. Okay, so I added the 4 on and added the 2y on, and then if you divide through by 2, we get 6x plus 2. After that point then, the mark was for substituting in, so you can see that I've done that here on this step. And you get a mark. Your third mark comes in at this stage when we've got ourselves a 3-term quadratic which we can factorise to solve for x. And then we've got a mark at the end for all of our solutions. Seems like quite a lot of work for that last mark, but just think you can get those first 4 marks in quite a straightforward way. The final topic I've chosen is functions. So the first question is finding inverse functions, kind of 4 steps to this. 3 are really just about notation though. So our first step is we're just going to set it equal to y. In our second step, we're going to make x the subject, so I'm going to add the 2 and then divide by the 3. And our third step is just swapping our notation back. So we replace the x with the inverse function notation, which is already on our answer line, and then we replace the y with an x. So we get x plus 2 over 3. Part B, you've got a couple of composite functions to work out. So it says that f of g of x is equal to 2 of g of f of x. So let's work out f of g of x. G is closest to x, so I'm going to substitute g into f. So that is replacing the x with our function for g. And we can expand and simplify this. We also need, so we've done that first part, we also need to work out 2g of f of x. So let's work out g of f of x first. So that's just a composite function the other way round. So I'm going to take f and replace it with x in my function g. So that's going to be 3x minus 2 all squared plus 2. We can expand that bracket. We'd get a 9x squared minus a 12x plus a 4 plus a 2. So altogether that's 9x squared minus 12x plus 6. So therefore 2g of f of x is 2 lots of 9x squared minus 12x plus 6. So altogether 18x squared minus 24x plus 12. The question tells us that f of g of x is equal to 2g of f of x. So we now know that f of g of x is equal to 3x squared plus 4. So I can just replace it. And we know that 2g of f of x is 18x squared minus 24x plus 12. So I'm going to replace that. The only difference now is that our function is set equal to 0, so let's subtract the 3x squared. We get that 4 is equal to 15x squared minus 24x plus 12, and let's take away the 4, we get left with 0, and 12 take away 4 gives us 8. That matches exactly with what they wanted us to show, so therefore we're done. Okay, again, a similar one then for you to have a go at. If you pause the video now, and then in just a second I will show you the answers. Okay, so here are our answers there. You can see the first question, what you should have got. Your first mark comes in for giving a method to change the subject. So for example, y equals 3x minus 1, or y, so I'm assuming that should say y equals 4x minus 1. And then you get the second mark only, and only if you get the x plus 1 over 4. And in part 2, your first mark comes in sorry, your first mark comes in for finding f of g of x, and that is as simple as just doing that first substitution. Okay, so not even getting to our simplified stage. And same over here, first mark just for the substitution. You get a mark for setting your two functions equal to each other. And I suppose your second mark there, that's saying it comes in if you've actually multiplied out the 2g of f of x correctly. And then the final mark is for finishing off your rearranging, setting it equal to 0. Okay. So what can you do now? I mean, I would go back to the beginning of the video. I would look at those topics that we said, haven't come up yet. Choose something from there. Choose something that's gone over in this video. And you've got all these websites on the screen that can help you. Okay, so go onto those. Look up the topic that you're looking for. If you want past papers, you've got some on Maths, Genie, and you've also got some on Revision. And good luck.